Can we start now? Boleh? Right. Let's continue from yesterday. So yesterday we have learned on the concept of hypothesis testing, right? And we already know what is the step or procedure to conduct a hypothesis testing. First step is to state the hypothesis statement, level of significance, test statistic. So in test statistic, I already taught you there are two type of test statistic, which is mean and proportion. Right. For mean, there will be known population variance known. Another one is population variance unknown. Right. For population variance known, we use Z distribution. When population variance unknown, we look into two conditions: n less than 30 and n more than 30, more than or equal to 30. So when n is more than 30, so we use Z distribution with unknown variance. And when n is less than 30, we use T distribution, right? And then we already look at some how to make a decision by the critical value approach. Another one is p-value approach, right? So then we have looked until example number 4. So I have many example here in my slide. So I think you should do example number 5 and 6 by your own. Let's look at example number 7 to refresh back your knowledge from yesterday, right? So suppose that 100 tires made a certain manufacturer by a certain manufacturer lasts on average 21,819 miles with a standard deviation of 1,295 miles. Test the null hypothesis mu equal to 22,000 against the alternative hypothesis mu less than 22,000 miles at 5% level of significance. So in this case, we have n equal to 100. And then the average X bar is equal to 21,819, right? And our standard deviation S is equal to 1295, right? So in this case, the population standard deviation is unknown, but the standard deviation and average come from 100 tires. So first we state the hypothesis statement. So mu equal to 22,000 and alternative hypothesis mu less than 22,000. And our alpha is 0.05. Test statistic will be Z distribution. This is unknown population variance, but sample size more than 30. So it should be X bar minus mu divided by S over square root of N. So this one should be 21,819 minus 22,000. So this is mu naught, right? So minus mu naught. Divide by standard deviation is 1295 divided by square root of 100. So this one should be negative 1.40. Right. Next, by using critical value approach, critical region. So our critical region, by looking at the alternative hypothesis, it should be skewed to the left. The region should be on the left hand side, right? So because it's less than, right? So the rejection area on the left hand side. So this is 0. This is negative Z alpha, right? Negative Z alpha only because we are measuring one tail test. So negative Z alpha is equal to negative Z 0.05. So alpha 0.05 It should be negative 1.645, right? And then rule, our decision rule, if Z calculated less than Z alpha, right? Just Z alpha, null hypothesis is rejected. So by looking at this Z calculated is negative 1.40, which is more than negative Z alpha. So since Z calculated, which is equal to negative 1.40, more than negative Z alpha, which is negative 1.645, null hypothesis is accepted. So if you look at the Z calculated, the value lies inside the acceptance area, right? So this is rejection area, and this is acceptance area, right? So since we accept null hypothesis, so the conclusion will be what is the conclusion? Oops. Right. So this is the conclusion. We conclude based on null hypothesis lah. So the null hypothesis is mean is equal to 22,000. Right. So now let's look at next example. You okay with this one? Right. Very simple, right? The thing is we need to know which test that we want to use, right? By looking at I already giving you the diagram, kan? So the diagram you should always refer to this diagram. So to choose which statistical test, you need to look at it one by one lah. This is a test of mean, population variance known, use that. Population variance unknown, look at these two conditions, and less than 30 and more than 30. All right, let's look at example number 8. This one. Example. This one. Yeah, right? Good. Belakang okay? Right, let's look at example number 8. So the steps are same, right? But the difference is the statistical test, right? So now specification of certain kind of ribbon call for a mean breaking strength of 185 pound. If 5 pieces randomly selected from different roll of breaking strength. So this is the value of 5 random sample, right? 171.6 until 189.1. So test the null hypothesis mu equal to 185 against the alternative hypothesis mu less than 185 at 0.05 level of significance. So now in this statement, we have n equal to 5. X bar, we need to calculate from the data, right? So X bar is summation of X divided by N. So you just input into your calculator, right? You know how to input into the calculator, kan? Let me put this one. So first, click on menu and 6, choose number 1, which is 1 minus variable. So we input one by one lah, 171.6 191.8, 178.3, 184.9, and then 189.1. Right? So you input all the five samples, right? And then you click on option and choose 3 for 1 minus variables, right? And you will get the result lah. So x bar is equal to 183.1. S is equal to, what is your value of S? 8.2190. Right, 8. Let's take 8.2 lah. 8.2 as a sample standard deviation. Right. So then the first step is mu equal to 185. So mu naught equal to 185. This is all the data that we have in this statement. Alternative hypothesis, mu is less than 185. Alpha 0.05. Then we take a test statistic. So in this case, the population variance are known, right? And the sample size is less than 30. So we need to use T distribution, x bar minus mu naught divided by S over square root of n. Right? So this is the formula for T distribution. So x bar is 183.1 minus mu naught 185 divided by standard deviation 8.2 divided by square root of 5. Right? Okay. So this one is negative 0.49. Right? So we are using T distribution instead of Z distribution. Next, we need to calculate the critical value or critical region. Right? So the area that we are looking for rejection is on the left hand side. Right? So this is 0. So T distribution also look like normal distribution because T distribution come from standard normal distribution power of 2 divided by chi-square distribution. So that's why T distribution will have degree of freedom. So this is negative T alpha with degree of freedom. Right? So DF is degree of freedom lah. So negative T alpha with degree of freedom. So degree of freedom is equal to n minus 1. So this is come from chi-square distribution. Right. So negative T 0.05, 5 minus 1 equal to 4. So degree of freedom is equal to 4. Right. So negative T 0.05, alpha 0.05, and degree of freedom equal to 4. So now we look at statistical table. Open our statistical table. In statistical table, we will look into table number 2. Right, table number 2, which is T distribution. Okay. So this is table number 2. The value of T alpha V, V means the degree of freedom in this case lah. Right. So it measure on to the right. Right. To measure to the right. So we need to find degree of freedom equal to 4 and find alpha 0.05. So this is the value of T 0.05, degree of freedom 4. Okay, which is 2.132. So this one is equal to negative 2.32. Sorry, 2.132. Right. So the decision rule still same as previous. Decision rule. If T calculated, so this is a T calculated, right? Lies inside rejection region, then we will reject null hypothesis. So in this one, if T calculated less than negative T alpha degree of freedom, null hypothesis is rejected. So our decision here is, since T calculated is more than negative T alpha with degree of freedom, null hypothesis is accepted. Right? So our degree of T calculated is 0.49, should be somewhere here. This is negative 2.132. Right? So our T calculated lies inside the acceptance region. This is a still same as previous. This is acceptance region. This is rejection area. Right? Yeah. This is degree of freedom, right? This is alpha. So this is alpha, our alpha is 0.05. Degree of freedom is n minus 1. So this is the value of degree of freedom, n minus 1. So our n is equal to 5 minus 1 equal to 4, right? Boleh? So since we accept null hypothesis, what is the conclusion? We conclude based on null hypothesis lah. So means that there are, so we can say that the role of ribbon right? So we do not have enough evidence to reject null hypothesis. Thus, the role of ribbon from which the sample was selected meet the specification. Right. Boleh? Any questions so far? Boleh? Can? So example number 9 should be easy for you, right? So example number 9, we're going to use this one. Can you read for a while? So we have n equal to 36. Sales people are selected at random. The number of contact made by each record for a single randomly selected week. The mean and variance of 36 measurement was 17 and 9 respectively. So this one, the population variance are unknown, right? And the sample size is more than 30. So we're going to use Z equal to X bar minus mu naught over S over square root of N, right? And what is the claim? The null hypothesis, right? Average no more than 15 people per week. right? So he would like to increase his figure. So mu equal to 15. Null alternative hypothesis mu more than 15, right? And then you calculate the T statistic, critical value, and make a decision. So example number 10. So in this example, later you do by yourself, right? So kita nak pergi topik yang lain pula lepas ni. Right. So we have a sample of 40 independent reading. So sample mean 128 and standard deviation 2.1. So it gives us the sample mean and sample standard deviation. Mean n is more than 30, so we use Z distribution, right? So Z equal to x bar minus mu divided by s over square root of n. And this one, null hypothesis, mu equal to 130. Alternative hypothesis, the test is less than 130. So mu less than 130. So this is a one-tail test, right? So later you do by yourself. Example 9. Yes. More than 15. Wait, example number 9. So you would like to increase this figure. Do you think? Right. Okay. Should be more than 15 lah. Right. So example number 11. So we have n equal to how much? N equal to 50, right? So for 50 specimen of alloy steel, the rock hardness in average 62 and standard deviation 8. So the sample size is more than 30. We don't know the value of population variance. So this one is the same example lah. Z equal to x bar minus mu naught over s over square root of n. And remember, when you answer this question, you need to follow the procedure lah, starting from hypothesis statement until conclusion, right? So the claim here is the manufacturer claim that alloy has at least 64. So null hypothesis mu equal to 64. Alternative hypothesis mu is more than or equal to 64. And our alpha is 1%. Okay. Right. For example number 12. So let's look at example number 12. Let's do together. So this is the last example for part 1. Right. So now, operator gasoline fuel vehicle complain about the price gasoline in gas station. According to the American Petroleum Institute, the federal gas tax gallon is constant 18.4 cents as January. So, but state and local tax vary from 7 cents, 7.5 cents to 32.1. So n equal to 18. So we have 18 data here, right? So n equal to 18 key metropolitan area around the country. The total tax gallon is this 18 location is given next. So dia bagi dalam table ni lah. So all the data, 18 data is given in this table, right? So what we are looking at is there sufficient evidence to claim that the average gallon gas tax is less than 45 cents, right? So from here, we need to calculate the value that we want. So we have n equal to 18. So this is, in this statement, we don't know the population variance, right? So we need to calculate x bar and S. Right. So the statistical test that we're going to use is T distribution. So if you calculate, later on you can calculate by yourself. So this one should be 39.556 and the standard deviation is 7.138. Right. So you calculate from this table, you will get this value lah. Right. So null hypothesis mu is equal to 45. Alternative hypothesis mu is less than 45. Right. Alpha equal to, if the value of alpha is not stated in the statement, so we will assume alpha equal to 0.05. I always remember. So test statistic, we will use T distribution x bar minus mu naught divided by S over square root of n. Right. So this one is 39.556 minus 45 divided by 7.138 over square root of 18. Right. So this one should be equal to negative 3.24. Right. So next, we need to calculate the critical region. Critical region. So the critical region, the rejection area is on the left, right? Because we are looking less than. So this is negative T alpha with degree of freedom. So negative T alpha with degree of freedom equal to negative T 0.05. The degree of freedom is equal to n minus 1. So n is equal to 18 minus 1 equal to 17. So this is 17. Right? So by looking at a statistical table, the degree of freedom equal to 17, right? And alpha 0.05, it should be 1.740. So 1.740, this one, the value of negative, right? So negative 1.740. Okay? Boleh? Right? So decision, since T calculated is less than, sorry, more than, less than, right? Less than negative T alpha with degree of freedom, null hypothesis is rejected, right? So to understand this, we just need to take this one, negative 3.2. So it should be lies inside the rejection area, right? So we reject null hypothesis. Okay. So then we make a conclusion. So what is our conclusion? So we have enough evidence to reject null hypothesis. We have enough evidence to reject null hypothesis and conclude that the average per gallon gas tax less than 45. Right? So this one should be down here. Okay. Any questions so far? No question? Easy, right? So provide you already understand yesterday lecture, then it should be very easy. Okay. So I have tutorial 1 until tutorial 8. So for this topic, right? So I think you can do by yourself. If you have any problem in answering question tutorial 1 until 8, so you can message me. Right? So for today, we're going to look on confidence interval and proportion. Right? Hypothesis for proportion and how to calculate the confidence interval. So, okay, boleh? Or you want 5-minute rest? No one. Dah balik awal. Okay, good. Right. So now, confidence interval based on sample data, two numbers are calculated from to form an interval within which the parameter is expected to lie. Right. So previously we already calculate the estimation of sampling distribution, right? So we got the value of X bar, we got the value of mean, variance, and standard deviation. So basically in real life, so there will be no exact value, right? So maybe the value of estimation will not be correct lah. So we need to estimate in terms of interval. So what is the value of mean will lies in two value of interval, right? So confidence level 95% implies that 95% of all sample would give an interval that includes the parameter that being estimated. So only 5% of the sample would yield the erroneous of interval. So this one, as I already explained yesterday, so we would like to minimize the error. So that's why we reserve type 1 error, probability of making a wrong decision, to be very small, 5%, 1%, or zero, or approaching to zero lah. And then we want to have a 95% and above confidence that our estimate will be correct, right? So the probability that confidence interval will contain estimate parameter is called confidence coefficient designated by 1 minus alpha. So 1 minus alpha is the probability of confidence, which is 95%, 99%, or 90%, right? So this is a form of confidence interval. We're going to have a lower limit, lower bound, lower confidence level, and upper confidence level, right? So this is the estimate of mean. So where theta 1 hat is the value appropriate random variable, theta 1 and theta 2, right? So the confidence interval or interval estimate of given parameter is not unique value lah, right? It's not unique value as previously we have seen in point estimate, right? So basically, the formula to calculate confidence interval contain point estimate plus minus margin of error. So margin of error is the standard deviation divided by square root of n. That is a general standard point of margin of error lah. Multiply with the critical value. So basically, we will have x bar plus minus z alpha divided by 2 multiply with sigma over square root of n. And this is what we call as margin of error. And this is point estimate. So the point estimate is calculated from the sample. Okay, this is the general formula, right? So now, same as previous. Yeah. No need to silent this one. Later we will discuss thoroughly. This is just an example, right? So confidence interval, same as previous, same as yesterday. We have two cases. So the first case is variance is known. The second case is variance is unknown, right? So if variance is known, we will use Z equal to X bar minus mu divided by sigma over square root of N, right? And when variance is unknown, so we will look to two conditions: N is less than 30, N is more than or equal to 30. So if N is more than or equal to 30, use Z distribution, X bar minus mu divided by S over square root of N. And this one, T X bar minus mu divided by S over square root of N. Right. But of course, we're not going to use this formula. So if variance is known, right? So the probability of confidence interval will be probability of X bar minus Z alpha divided by 2. This is alpha. So sigma over square root of N mu 1. So this is X bar plus Z alpha divided by 2 sigma over square root of N equal to 1 minus alpha. So this is the formula for variance is known. When variance is unknown, we just replace the margin of error. So the margin of error, right? Z alpha divided by 2 S over square root of N. For N less than 30, the margin of error T alpha divided by 2 with degree of freedom as square root of N. Right. The value of point estimate are same lah. So the thing that we've changed is the margin of error for this confidence interval. Right. If you follow this diagram, then I think it should be okay. Right. You can use, you can identify what type of statistical test that you want to use. Right. So now, theorem number 1. If X bar is the mean of random sample size N from a population with known variance, right? So 100, 1 minus alpha percentage is confidence interval for mu. This is confidence interval for mean, right? Is X bar minus Z alpha divided by 2 sigma over square root of N. So this is minus, this is plus, where this is lower confidence limit and this area is upper confidence limit. So we are looking into the estimation of mu, mean, right? So 100, 1 minus alpha percentage is the level of confidence. Let's say if alpha equal to 0.05, the level of confidence will be 95%, right? Okay. Done? Done. Right. So this is theorem number 1. So if population variance is unknown, right? As I said before, population variance unknown. The sample size is non-normal distribution, right? We can use central limit theorem when sample size is approaching to infinity by using Z distribution as divided by square root of N. So we change the margin of error, right? So let me put into a proper diagram. So let's revisit this one again. Right. So let's say we have two cases. So confidence interval for mean, right? So we have two type of two conditions. So population variance known, population variance unknown. Right. So for population variance known, we will use probability of x bar minus z alpha divided by 2 sigma over square root of n. This is mu x bar minus plus z alpha divided by 2 sigma over square root of n. This is 1 minus alpha. Right. So when the population variance is unknown, when n is less than 30, right? So we will use probability of x bar minus t alpha divided by 2 degree of freedom s over square root of n, x bar plus t alpha divided by 2 degree of freedom s over square root of n. This is 1 minus alpha. So when n is more than or equal to 30, right? So basically we will use this one again. Right, let me copy. But the difference is we're not going to use sigma. We are using S, standard deviation from sample. Right. So this is a general formula for finding confidence interval for mean. When population variance known, we use Z alpha divided by 2 sigma over square root of n for margin of error. For n less than 30, use T distribution. N more than 30, use Z distribution. Okay? Boleh? Any questions so far? Right. Let's look at example number 13. So example number 13, standard set by government, a government agency indicate that Malaysians should not exceed the average daily sodium intake of 3,300 milligrams. And standard deviation of daily sodium index is 1,100 milligrams. So this is a population standard deviation, right? So to find out whether Malaysians are conforming to this limit, a sample of 100 Malaysian is selected. The mean is found to be 3,400 milligram. So at 5% significant level, is there evidence to support the claim that mean daily sodium differ from 3,300? Right. So our n here is equal to 100. X bar equal to 3400. Sigma is equal to, what is the value of sigma? 1100. Mu naught equal to 3300. So null hypothesis, mu equal to 3300. Alternative hypothesis, mu is not equal to 3300. Alpha equal to 0.05. Test statistic. So we are using Z distribution with population variance known, right? So X bar minus mu divided by sigma over square root of n. So this one is 3400 minus 3300 divided by 1100 over square root of 100. So this one should be equal to 0.91. Okay. Critical region. So since this is a two-tail test, so the rejection area going to be on both sides. So this is Z alpha divided by 2. This is negative Z alpha divided by 2. So Z alpha divided by 2 is equal to Z 0.025, which is 1.96. Right? So this is negative 1.96 and 1.96. Okay. Our decision here is since Z calculated is less than Z alpha divided by 2. This is 0.91 less than 1.96. So null hypothesis is accepted. So our conclusion is we don't have enough evidence okay. Right. For the second question is find the p-value for the test. What is your conclusion? Right. So this is two-tail test. So for two-tail test, the p-value for two-tail test is 2 multiplied with 1 minus probability of Z less than Z calculated. So this is absolute. Huh? So this one should be 2, 1 minus probability of Z less than 0.91. So if you look at the statistical table, 0.91 should be 0.8186. So 2 multiply 1 minus 0.8186. So this one should be equal to 0.3628. Right? So our decision is since p-value is 0.3628 more than alpha 0.05, null hypothesis is accepted. So we conclude based on the alternative hypothesis, the null hypothesis lah. So the conclusion are same as this one. Okay. All right. Okay, the last question is we need to construct 95% confident interval of daily on mean daily sodium intakes. So since the population variance are known, so sigma is equal to how much? 1, 1, 0, 0, uh, n equal to 100, x bar equal to 3400, right? And then mu naught equal to 3300. This one not applicable. So we would like to find 95% confidence interval alpha 0.05. So probability of x bar minus z alpha divided by 2 sigma over square root of n mu x bar plus z alpha divided by 2 sigma square root of n. So 1 minus alpha. So this one should be probability of 3400 minus z alpha divided by 2 z 0.05 is 0.025 equal to 1.96. So 1.96 multiply with 1100 divided by square root of 100. So same goes to the right hand side. 3400 plus 196 multiply with 110 square root of 100. So this is 95%. Okay. So you calculate this one, you will get the probability of 3184 3184.4 mu, and this is 3615.6 equal to 95%. So our estimate just now is x bar is equal to 3400, right? So 3400 is inside the interval. So since the value of x bar inside the interval, our estimate, right? Our claim 3300, right? Okay, x bar is our claim is 3300 inside the confidence interval. So means that there are no significant difference, right? So this is how you interpret the confidence interval. So we have 95% confidence that the mean sodium intake is between 3184 and 3615. Since the value of mu, the claim 3300 inside falls inside the interval, so we are going to accept null hypothesis, right? If the value of mu naught outside the confidence interval, we will reject null hypothesis. Okay? Boleh? Okay, boleh? Right, let's look at example number 14. I think you can try. This is a same example. Example number 14. Example number 15, easy, right? It's the same as previous. But example number 14 is a bit different. But in this example, I would like you to derive the confidence interval from scratch. Means that, let's say this is theta hat is a statistic from a normal distributed with mean equal to theta and standard error theta sigma theta hat. So we want to find the confidence interval that for theta that post confidence coefficient 1 minus alpha. So it start from the scratch negative z alpha divided by 2. This is z alpha divided by 2, 1 minus alpha. Well, this in this case 1 minus theta lah. Right. So z, we know z is x bar minus mu over sigma over square root of n, right? So we just replace the z value, z alpha divided by 2, x bar minus mu sigma over square root of n. This is z alpha divided by 2, right? So we bring this value to both sides, right? So it should be probability of negative z alpha divided by 2 sigma square root of n x bar minus mu z alpha divided by 2 sigma square root of n 1 minus theta, right? And then we bring x bar to both sides, right? And we leave mu on the middle. So probability of x bar minus z alpha divided by 2 sigma over square root of n. Right, that's all. Okay. So this is how we derive the confidence interval from the Z distribution. But this kind of question not going to be in your test lah or final, right? This is part of mathematical statistics subject. Okay, done. So example number 15, 16, I think you can do by yourself. And 17 also, right? So for 15, this is Z distribution. 16 also Z distribution. 17 Z distribution, right? Should be simple, right? Now let's look at theorem number 2. This is about T distribution when the variance, population variance are known, right? And the sample size is very small. We're going to use T distribution, right? Okay. You all okay, ga? Boleh? Right. So basically it's a simple thing, right? So just repeat over and over again. So now let's look at example number 18. So example number 18, the flow discharge of Perak River was obtained at random, right? 20 readings were collected. The mean flow discharge will be 3.85 with standard deviation 0.5. So we need to test the hypothesis mean flow discharge Perak River not equal to 4 meter cube per second. Use alpha 0.05. Right. So we have n equal to 20, x bar equal to 3.85, and s equal to 0.5. So null hypothesis mu is equal to 4. Alternative hypothesis mu is not equal to 4. alpha 0.05, test statistic. So this one we're going to use what distribution? Z or T? T distribution because N is less than 30, population variance unknown, right? So T equal to X bar minus mu divided by S over square root of N. So this one should be 3.85 minus 4 divided by 0.5 over square root of 20. This is 1.34, right? So based on the alternative hypothesis, this is two-tailed test, critical region. So we have two-tailed test, two rejection area. Right. So this is negative T alpha divided by 2 with degree of freedom, T alpha divided by 2 with degree of freedom. So T alpha divided by 2 degree of freedom, T 0.025, the degree of freedom is N minus 1 should be equal to 19. So this is 19, right? The critical region 0.025 and 19, right? So we look at a statistical table. Degree of freedom equal to 19. 0.025 will be 2.093, right? Okay. So this is 2.093. It means that this is 2.093 and this is negative 2.093. So to make a decision, so our T calculated is less than negative 2.93, right? So since T calculated less than negative T alpha divided by 2 with degree of freedom, null hypothesis is accepted, right? So we look at this one is before the critical value, right? It lies under acceptance region, right? So we make a conclusion. So what is our conclusion? We don't have enough evidence we conclude that the true mean flow discharge is not significantly different from 4M at 5% level of significance. Okay. So this is by using critical value approach, right? So still remember yesterday, I already provide you a slide to calculate the p-value, right? Where is the slide? This slide. So this is the slide for calculate p-value for Z distribution. And this is calculating p-value for T distribution. So for T distribution and Z distribution, it's slightly different, right? even though the formula are same, but we don't have a specific value for specific p-value for t distribution, right? So now, second question here, use p-value to calculate to conclude the null hypothesis. Okay, now in this case, listen carefully this one, huh? P-value, right? So our n is equal to 20. Our degree of freedom equal to 19. Our t calculated equal to negative 1.34, right? So the p-value is equal to 2 multiplied with the probability of t degree of freedom more than the absolute of t calculated. So this one should be negative 1.34, right? So 2, we look at this one, this table, degree of freedom equal to 19. Degree of freedom equal to 19. The absolute 1.34, right? 1.34 is our t calculated, right? The value less than 1.34 is between, so 1.34 is between 1.328 and 1.729, right? So degree of freedom 19, and we try to find value of 1.34. So we cannot find 1.34 in this table, right? For degree of freedom 19, but the value of 1.34 is between 1.32 and 1.72, right? With alpha 0.05 and 0.10, right? So the p-value actually will be somewhere between these two values, right? So it should be, should be 0.05 p-value until 0.10. Okay, look at this table again. The 1.34 between 1.32 and 1.7. So the p-value, our p-value should be somewhere between 0.05 and 0.1. So since this is a two-tailed test, we need to multiply with 2, should be p-value should be 0.1 and 0.2, right? So you will multiply with 2, right? So since alpha equal to 0.05, our p-value, since p-value is more than alpha 0.05, null hypothesis is accepted. Boleh faham this one? Can you understand? We cannot find the exact p-value in t statistics, right? But sometimes we can get the exact value, but most of the time we cannot estimate. So since the p-value is 0.1 to 0.2, which is more than 0.05, so we accept null hypothesis, right? So the decision using p-value approach and critical value approach should be the same, okay? And we conclude based on the null hypothesis lah. So we conclude based on this one, okay? Boleh? Any questions so far? No question? Then we move to the next question, which is construct 95% two-sided confidence interval on mean flow discharge. What is your conclusion? So we know that this is unknown variance, unknown population variance, and less than 30. So 95% confidence interval. So this is C, 95% confidence interval. So we have X bar equal to 3.85, S equal to 0.5, N equal to 20. And we should know T alpha divided by 2, N minus 1, T 0.025, 19 is equal to 2.093. This one you already calculate just now, right? So the confidence interval probability of X bar minus T alpha divided by 2 N minus 1 as square root of N X bar plus T alpha divided by 2 N minus 1. N minus 1 is the degree of freedom, right? S over square root of N equal to 1 minus alpha. So this is 3.85 minus 2.093 multiply with 0.5 over square root of 20. Okay. And when you calculate this one, you should get 3.616, 4.084. Right. So we can conclude that we have 95% 95% based on the alpha value, right? 95% confidence that the mean, the true mean is between 3.616 and 4.084. So based on the null hypothesis testing, we are testing mu not equal to 4, right? So since 4 inside the interval, we accept null hypothesis. Means that there are no significant difference. Okay? Boleh? Right. So for example, number 19 until 24, you can do by yourself. Right? Provided you understand the first example. Okay? Boleh? You want 5-minute rest? Okay. All right, let's continue. This is the last part of chapter number 7. And next week, we will have quiz number 2. We'll cover until chapter number 7. Okay. Most probably online lah. And I would like to prefer multiple choice question. Right, but it depends on Dr. Ibrahim lah. Okay. So test about proportion. So test about the proportion. Many hypothesis testing situation involve proportion, right? Such as 59% of consumer purchase give for their fathers, 51% Malaysian buy generic product, and so on lah. So this is an example of proportion. Right, so if you have a proportion, the Z statistic or test statistic that we're going to use is Z distribution. But in this case, we use P hat minus P naught divided by P or multiply with P, Q over N square root. And P hat is equal to X over N, and P is equal to proportion, and equal to sample size, right? So basically that's all. If you have a proportion problem, right? So let's look at this one. So 3 test problem about proportion, right? So same as previous as mean. So if you have null hypothesis P equal to P naught, the alternative hypothesis can be P less than or P more than P naught. So this is a one tail test. And we also have P not equal to P naught for two tail tests. So when we have a proportion problem, the Z distribution is P multiply P hat minus P naught, PQ divided by N, and taking square root for denominator. And P hat is equal to X over N. So this is a statistical test for proportion. Right. So we're going to use Z distribution lah. So the critical region and p-value approach are same as previous, right? So decision rules is more sama lah, right? So now let's look at example number 25. So in example number 25, so 20% of Malaysian adult participate in fitness activity at least twice a week. A local survey of 100 adults over 40 years old, right? A total 30 people indicate that they are participate in fitness activity at least twice a week, right? So in this case, we have N equal to 100, X equal to 30 who participate at in fitness activity at least twice a week. So we want to test whether do this data indicate that participant rate adult for over 40 years age is larger than 20%. So we need to carry out 10% significant level. So alpha equal to 0.10. The hypothesis in this case, it's not mu. This is a proportion case, right? So it should be P equal to 0.20, which is 20%. We want to measure the proportion at 20%. And alternative hypothesis, P more than 0.20. Alpha 0.10. Test statistic. We're going to use Z distribution. P hat minus P naught. So this is P naught, right? P naught. Okay. This is P naught. So divide by P hat Q hat over N, taking a square root for this one. Right. So P hat is equal to X over N, which is 30 over 100, which is 0.30. And Q hat is the complement of P hat, which is 1 minus P hat, 0.70. Okay, this one, understand? So this one should be 0.30 minus 0.20 divided by square root of 0.3 multiplied with 0.2 divided by 100. So this one is going to be 2.5. Right? So next procedure are same as previous. Right? Next step is we need to find the critical region. So this is one tail test, right? Look at the null alternative hypothesis more than 0.2. This is one tail test. Critical, yes. Oh, so this is 0.7 lah. Critical region. So properly put 0.7. Okay. So the region will be, the rejection region should be on the right hand side, right? So this is 0. This is a rejection region. This is Z alpha, right? So Z alpha is equal to Z 0.10. So 0.10, 1 minus 0.1 should be 0.9. So look at the statistical table. Z statistic 0.9 should be somewhere here, right? Okay. Should be somewhere here. Maybe 1.28. Basically 1.8, 1.28 something lah. Right. 183. 1.283 actually, the exact value. But we don't have the exact value, we can estimate, we can take 1.2, 1.28 lah. So this is 1.28. So our decision is since Z calculated is more than 1.28, which is Z alpha, null hypothesis is rejected. Okay. Conclusion. A strong evidence that the participation okay. Yes. Alpha 0.1. Yeah, we are taking alpha 0.1. This is 0.1. So 0.1, you mean that when you want to take the value from the table, okay? Right? So 0.1 is to the right, right? But in this table, we read the value given to the left. So we need to take the complement lah, at 0.9. Boleh faham? Okay? Right. This one okay dah? Dah? Question? Belum? So I am recording this lecture. Later I will post into my YouTube channel. Then you can rewatch it again. Yeah. Okay. All right. Let's look at the second part. Basically, this is the last part, right? We don't have any more. So the confidence interval for proportion. So previously we have looked into confidence interval for mean. We have three types, right? When the population variance are known, n less than 30, more than 30. Another one is population variance known, right? We use that distribution. Right. So the confidence interval is basically same general using a general formula juga lah. So which is a point estimate plus minus margin of error. So in this case, margin of error is Z alpha divided by 2 P hat Q hat divided by N, and we're taking the square root here. Right? So this is the margin of error. The point estimate is P hat. Okay. So you can read my previous slide in this topic, right? The conversion from binomial problem to Z distribution. Actually, we have looked this one in chapter number 4, kan? So when NP and NQ more than 5, right? So let's look at example number 26. So find 90% two-side confidence interval proportion of age. About 20% of Malaysian adults participate in fitness activity at least twice a week. A total of 30 out of 100 people indicate they are participating in fitness. So this is based on example number 26, 25. So X is it. So this is X equal to 30 and equal to 100. And then the proportion P naught is equal to 0.20, right? So the confidence interval, 90% confidence interval, P naught, P hat minus Z alpha divided by 2, P hat Q hat over N, taking a square root. This is P hat plus Z alpha divided by 2 P hat Q hat over N square root. This is 90%. This is 1 minus alpha lah. 1 minus alpha. So we input the value into the formula. P hat is equal to 0.3, right? Where we take 30 over 100. And Q hat is equal to 0.7, which is the complement of P. So P 0.3 minus Z alpha, Z 0.05, right? This is alpha divided by 2, right? Z alpha divided by 2, Z 0.10 divided by 2. Z 0.05. This is 1.645, right? So how to know 1.645? So look at the statistical table. 0.05, 1 minus 0.05 is 1 minus 0.05 is 0.95. So 0.95 should be somewhere between these two value, right? 1.6, 4, and 5, right? 6, 4, 5. So this one should be 1.645 multiply with the square root of 0.3, 0.7 over 100. 0.3. Okay. If you calculate the value, you will get a probability of 0.2244, 0.3756. So in confidence interval, normally we will put 0.2244 until 0.3756 or 0.2244 until 0.3756. Either method are correct. So this one also correct, this one correct, this one also correct. Okay. Boleh? Oops. Hey, don't forget to sign in your attendance. Done? Sound okay? So I have example number 27, 28, 9, 30, and I have some exercise for you. This is compilation of Z population test of about mean and proportion, right? So let's try to look at the last example lah, example 27, and then the balance then I think you can do by yourself lah. Okay. So a researcher claimed that based on the information obtained from the Centers Disease Control and Prevention, 17% young people aged 2 to 19 are obese. Test this claim, she randomly select 200 people to age 2 to 19 and found that 42 are obese. At 0.05 level of significance, is there enough evidence to reject the claim? Right. So null hypothesis P equal to 0.17. And alternative hypothesis P is not equal to 0.17. This is alpha 0.05 and we have n equal to 200, x equal to 42, p hat equal to 42 over 200, which is equal to 0.17. No, 0.21. Right? And the Q is the complement, 1 minus 0.21 equal to 0.783 lah. Is it 83? 79, right? 79. Okay. This is example number 27. Okay. So test statistic. Z equal to P hat minus P divided by square root of P hat Q hat over N. So this is 0.21 minus 0.17 over square root of 0.21 multiply with 0.79 divided by 200. So what is the value? That 1.3 here. 1.38, right? Is it? You got the same? So this is a two-tailed test, right? So critical region. Um, so we have rejection area to the left and right. So this is negative Z alpha divided by 2 and Z alpha divided by 2. Z alpha divided by 2 is Z. This is 0.05, right? This is 0.025, which is 1.96. So this value is 1.96 and this value is negative 1.96. And our decision is, since Z calculated is equal to 1.39, so since Z calculated equal to 1.39 less than Z alpha divided by 2, 1.96, null hypothesis is accepted. Right? And we made a conclusion. So what is our conclusion? There is not enough evidence to reject null hypothesis or to reject the claim lah. The claim that 17% of young people aged 2 to 19 years are obese. If you are using p-value method, how do you do it? P-value method, p-value. So this is two-tailed test, right? 2 multiply 1 minus probability of z less than z calculated. Right, so this is 2 multiply with 1 minus probability of z less than 1.39. So 1.39 should be somewhere, this one, 0.9177. So this is 2 multiply 1 minus 0.9177. It should be 0.1646. Since p-value is more than alpha, null hypothesis is accepted. Okay. Any questions so far? Right, I think that's all. We finished chapter number 7. So example and exercise that I did not attend tadi tu. So you boleh buat sendiri lah. If any question, you can message me. Right, thank you very much. Assalamualaikum.